On page 5 of our Unit 3 notes, we are looking at special solutions to inequalities. When we were solving equations, the guidelines as to special solutions were pretty straightforward. If we got to the case where one constant equaled another constant that weren't actually equal, let's say 3 equals 5, those aren't equal, so we would write no solution. If we found that a constant equals a constant, but those were in fact the same constant and they were equal, that was the all real number case. Now, when we're working with inequalities, it's not quite so straightforward. Let's look at this first case. Using the distributive property, we end up with 3x plus 3 is greater than or equal to 3x plus 5. Now, we know this is a special solution case because just like with equations, when we have the same coefficient in front of our x terms, those x terms will disappear and we will be left with constants on either side of, in this case, the inequality symbol. Now, this would be an automatic no solution if this were an equation, since 3 does not equal 5. But now our question is 3 greater than or equal to 5? Is 3 greater than or equal to 5? No. False. You can write false if that helps you, or no, or cross it out. They are not equal, and therefore this is no solution. But the reason it's no solution is not just because 3 doesn't equal 5, it's because 3 is not, in fact, greater than 5 either. This inequality has the same basic setup, only our inequality is different. Now, instead of a greater than or equal to sign, we have a less than sign. Same steps to solve, except now the question we're asking ourselves is 3 less than 5? Yes. Yes, 3 is less than 5. That's not my answer. False is not my answer. My answer is all real numbers with my fancy R. Because 3 is less than 5, whatever I plug in here for x, the left-hand side of the equation will be less than the right-hand side of the equation, and therefore any x that I plug in here, any real x, will make this inequality true. Let's look at these bottom two. 2x plus 1 is greater than or equal to 2x plus 1. Again, we can immediately identify we have a special solution because same coefficient in front of the x terms disappear, and we ask ourselves, is 1 less than or equal to 1? Yes. Yes, it is. True. True. 1 is not greater than 1, but it is equal to 1. So 1 is greater than or equal to 1. This is an all real number situation. Same setup, except now we have a greater than sign. Now the question we ask ourselves is 1 greater than 1? No, 1 is not ever greater than 1, and therefore, because that is false, optional, you don't have to write that, we're going to write no solution. So to recap, you can't just memorize something like we could with equations. Constant equals constant, all real numbers, constant equals constant that aren't actually equal, no solution. You just have to solve until you get to a constant on either side of the inequality and then ask yourself, is this inequality true? If it's true, then the solution is all real numbers. If the inequality is false, then there's no solution to the given inequality.